Good afternoon. Thank you for coming. Today, this technical symposium basically is about half an hour. So if you this is very quick introduction talking about our HEDPS, or the short term we call it HEDPS. Okay. So my name is TD Lee. So basically I'm actually co-founder of I-Chem Solutions. So basically this is talking about high efficiency deionized purification system. Short term we call it HEDPS. This unit generally I think is actually been developed out together with this Zhejiang University, and they are one of the incubator. This their technology center in the Zhejiang University. So the today presentation is very short. It's about 20 minutes. We have about 5 minutes video presentation. Then probably have some 5 minutes Q&A if you have any question on that. So first, very quickly, I will talk about some introduction of I-Chem Solution Group. Then what is HEDPS? The key thing here, I probably will comparison. I will give you a comparison between HEDPS and mixed bed. What actually is the difference between these two? Then also I will compare comparison between the EDI and the HEDPS. So this is a very good comparison. At least you have some idea over that. Then the video presentation on the HEDPS and question Q&A time. Okay, the story began actually. I-Chem Solution actually we started from Malaysia. Actually we are from Ben Meyer basically. I started in Ben Meyer. So in year 2000. So from year 2000 until year 2006. It's under incubator under I-Chem Technochemical, but what happens is that in 2006, 2005, we decided to move out. So then we formed I-Chem Solution. Then from there, we actually formed a company. Then today, I would say that we have been present in Malaysia, Thailand, Indonesia, Singapore, Vietnam, Bangladesh, Myanmar, Laos, Cambodia. I think this is actually the Philippines. We have a present. Basically, we are a regional-based company, but all my HQ is actually in Malaysia. Okay. So today I will say that we have a team with the green shirt running around in the exhibition. You know that we have almost about combined all my technical staff. All this is an engineer. They are the chemical engineer or mechanical engineer. So all this one more than 200 years experience now. So all my, I would say that my management staff, minimum 20 years in the water treatment field. So we are actually been working with others in the MNC company. So this is how we work. So you can see that we are not just strong in the chemical side. I-Chem Solution, we are strong in the biological side also, biological treatment. So we have also set up a very comprehensive lab where actually we can analyze all the wet chemistry, deposit analysis, resin, product development, R&D. This is part of we say HEDPS basically is just our R&D together with other university. So what we also optimize all this one need specification on the water. So I-Chem Solution for the past 15 years, we are very focused in water only. Okay. So this is a key in all this one, independent monitoring. I think the key thing here, we cooperation with a lot of universities in Malaysia, in Taiwan, in China, in Korea for product development. So that is actually how we come out a lot of new innovation way. We wouldn't say it's a new product, but it's more towards innovation way to run the system to get a clearer water. So this is some award that normally we receive over the years, and this is a whole team. We are our team that running around in the region. So this is three main our products running brand name in the market. BM Solution, I2EX, which is a resin, ion exchange resin, Anticon, which is all the filter media. Alright? So this is the chemical, or we say our product coverage overall, all related with water, from raw water, cooling boiler, wastewater, ultra pure, swimming pools, that you name it. We have this, we call it a know-how over this one. Then this is a key thing. Actually, our mission and the I-Chem Solution is very clear. We want to make water cleaner, safer, healthier, and the keyword is called sustainable. How to actually do the sustainability? Because then you put less chemical, use less polluted chemical, use less safe water, then definitely this, I would say, the water can be more and more better for our next generation. Okay. So that now we actually go into the HEDPS. It's actually still, but what they do is more toward the process. You know that nowadays people are talking about Industrial 4.0, where actually we have to go in system, you actually can be fully automated. So that is actually the one of the direction that we work together. So with the university and us, then we come out the idea. Then after that, this is about 3 years type of job, 2 years of research. Then they come out, then they patent it. Then now this unit basically we say that is fully distributed for ASEAN country plus Sri Lanka and Bangladesh. It's by I-Chem Solution Group. All right. So this is actually one of the signing ceremony where actually they are. The center one is the inventor, which is one of the professor. So they actually come out, then they sign, then we work together. We come out and sign the ceremony. Then with that one, now we actually officially we can actually really promote that. So I want to give you a very quick run out on this one. This unit basically you can say on the feed water quality. It depends on what output you want. The output water can be 5 mega ohm in terms of water quality, 5, 10 or 15. Then that will actually determine what your input should be. So your input can be actually from below 20 microsiemens after RO or below 100 microsiemens after UF. Why we must have the pre-treatment after RO or after UF? That is because this resin is actually only about 10 cm to 15 cm high, and there is no free space. So they are not tolerate on the, we call it no toleration on the suspended solid. So mean to say that SDI itself, it must be quite good. It's been normally we control, if you talk about SDI, you want to control below 5. You want to control below 5. So the feed water temperature, we say 15, that's the normal, we are normal temperature. But the key thing here, Regeneron is still using, we call it a purified hydrochloric acid and purified caustic soda. Feed water temperature 2 bar to 10 bar. That's actually we can run that flow. Then the key thing here, I think the regional consumption actually is compared to a normal resin, normal twin bed or mixed bed, where you require 200 to 250 gram per liter resin. In here, probably you require about 30 to 50 gram per liter. So that's how we actually work it out. Then later I will show you on terms of comparison how much the saving on the Regeneron side. Then you are talking about also this one, the ratio. For this resin, for this system, the rinsing time and the Regeneron time is very, very short. Normally, our program, you will run only about 10 minutes. Mean to say, for the twin bed, for the K-anic, normally you will run almost about 3 minutes. For N-anic, another 3 minutes. The rinsing time, about 4 minutes, then back to service. So, whole process is about 10 to, the most longer you can actually program it up to 15 minutes. 15 minutes. That's it, how you want to control your output quality. But if you have a very, maintain, let's say 10 meg, then you can actually run that one, we call it shorter. So then instrument air, you probably, the pre-treatment requirement actually you have either UF or RO, the reverse osmosis. Then this is, and the IoT is all axis. This is fully a PLC system where all the data have been have a data logger inside there. So you have a data of every 10 minutes. So you can plot the graph, you can actually know what is happening in the system over the midnight, because this one is actually, generally you don't need any people to be there. It will running fully auto. Okay. The water quality outlet, I would say you will require about 5 to 10, 5 to 15, depending on the input. 5 mega ohm is the lowest, normally we can actually say about 0.2 microsiemens. For some boiler feed water, medium pressure boiler feed water, that's good enough. For some electronic, probably they will look into 15 Then you go into some, we call it electronic grade polishing to get to 16.8. That is actually for electronic side. So this is a modular we normally currently available, 10 meter cube per hour flow rate, with either this one, the water quality, or 25 or 50. It depends on the bigger size. We can design custom made. We still can custom made up to 100 meter cube per hour, but that one need to be customized because that will be actually depending what quality you prefer. We can customize up to 100 meter cube per hour. Okay, but this is talking about the modular we want to promote in the market. Okay, this HEDPS basically is working principle is very straightforward. Actually, it's same thing. It's actually with all the KRNA passing through this one, you will get your H. Then the water you're passing through another anionic, the modular. Then you will come out OH. Then you combine, they will get the H2O. It's actually exactly the same like your twin bake resin, except what happened here actually they remove out your exhausted resin zone, the ready to regen, ready to serve zone. You only take the working zone. You only take the working zone out here. So that's the reason why you only have about 10 to 15 cm height resin in the vessel. So this is a comparison between mixed bed and HEDPS. Okay, I give you a very good example. This is a system flow rate of 25 meter cube per hour. Water quality required probably is about 10 mega ohm, more than 10 mega ohm. So water saving, you can imagine, if you talk about regeneration step for the mixed bed after RO, you want the mixed bed running. So your regeneration probably is about 5 days, 120 hours per regeneration. So you require running this one probably I would say around 4 to 6 hours regeneration time per regeneration cycle. 4 to 6 hours. And the water you use normally per regeneration is about 30 meter cube. So you have to have a clean, good water, our water, 30 meter cube for the rinsing time. But in here, you just imagine, if you based on this one calculation, your water total consumption of this one, or the good water, is about 2,200 meter cube per year. But based on the HEDPS, your regeneration time, everything, I would say, is about this. 3, 3, 4, or 4, 6, it depends on it, it's about 10 minutes per regeneration time. Each time, regeneration cycle is about 6 to 8 hours, normal. We are currently, our unit running in Senawang side, up to almost 30 hours because they are not running continuously. I would say that, but actual one, we will probably run continuously, it will run around 6 to 8 hours per cycle. One cycle, you only use up about 1 meter cube water. 1 meter cube for rinsing. Then, total water saving, you will save per year, this is about 1,005. It's about 1,005. So you are talking about here, you are saving per year, close to about 700 meter cube on water saving. Okay, this is I'm talking about the mixed bed. How about their chemical consumption? I think this is something more interesting. You talk about chemical consumption side. You based on the 25 meter cube, if you look based on the resin volume of this one, if we based on the calculation, we need about 850 times this one, because normally you need about 100 gram, 100% per liter of this resin. You put based on this one, you work out it's close to 200 liter of 33% acid. So then you work it out, you require every year about 14-15 ton per year. But if you compare this one, you can just imagine here, the resin volume here is about 60 liter. 60 liter, then you need only about 2.4 kilo per regeneration. So you time all this thing out, based on the 6 to 8 hours, your total consumption is about this one. 3.5 ton of acid compared to this one. So your saving here is almost 80%. But this also depends on your output quality. Which water quality you want. If you want 10 meg, that's the one. You want 50 meg, this one probably will be shorter. The regeneration time may be actually focused. It's different. Okay? But the cycle time, basically, this is how they calculate out. So saving on the chemical consumption is actually a plus point. It's a plus point here. Okay. Then we are talking about on the mixed bed compared to a HEDPS, how actually on the maintenance side. Because this one, 3 to 5 years, I would say resin, you need to change it. Normally 3 to 5 years, depending on the operating side. Here is the same thing. We also need to probably change it 3 to 5 years. But because we only very focused on the exchange side, we are not focused on the suspended solid, the fouling, all this one. So then this thing, we only change the module. You come in the, because this resin is packed in with like a cake. So you only come in when it's something like a plug and play. So you change your anionic modular, you plug in, within probably half a day, then you can run back. Rather than if you talk about mixed bed, I would say that easily you require probably about 2 days just to put it back to service again. Okay, so this is how you compare between the mixed bed and the HEDPS system. Then how about EDI? You see, EDI, most of the time people are talking about EDI because EDI, so far they can actually produce the best water quality and without any people interfere. Not like mixed resin. Resin, you need a lot of regeneration, then people have to put a lot of attention and you need a skilled worker to do that. But EDI, one of the drawbacks of EDI, I think here probably you all should know. EDI, to run EDI, you need a 2-pass RO. 1 pass and 2 pass. 2-pass RO, why? Because EDI, one of the bad drawback on EDI is EDI require a very good water quality. Generally, they require very low silica level in the water. That's why they run 2-pass RO. For HED, you only need to run 1-pass RO. 25 meter cube, 10 Mac water quality. Same thing, you only need to run 1-pass RO. You don't need 2-pass RO. Then you will say that the lifespan here, when you change the EDI, is a module. One module, you change everything. One module currently probably costs us about 20,000, 30,000, depending on which model you are taking from Taiwan, from US. It's easily that. Then you have to replace everything. So here, what you need is you only replace the module. The system, everything is just pump, valve, piping, the controller. That's all. You only take it out, put it back. So that is actually how easy is it. So the maintenance cost itself, definitely compared to EDI, the payback is much better because EDI you have to change everything, the module. Then EDI, I just now mentioned 2-pass RO, 1-pass RO, as low as possible. Reject water, let's say you are talking about, you need about 16 meter cube compared to 8 meter cube for 1-pass RO. So mean to say that if I run 25 meter cube, this one I need to have about 46 meter cube feet for the pass, for the engineer. So I need a bigger pump to run 2 pass. But this one I only need about 25, 33. I put a smaller pump so I can save on my investment side. Then all this one, you can see no regeneration, but EDI, basically water reject, can back to RO storage, then you can use back. Same thing here, but here you need no reject, but you can also reuse back this water, put back to the front, neutralize and can put it back. If you have this one also can. So if you compare on the water side, reject water comparison on this one, you just imagine 2-pass RO 41, so you get 16. So your recovery is about 60%. So annual water rejection, you are talking about 140,000 meter cube reject water. But you are running on the single pass RO, you are only running 75% recovery. This is very normal. 70,000. So just imagine on the water rejection side. You have here immediately, this is not talking about HEDPS, but talking about the process of water before going to the HEDPS or before going to the EDI. The water is already saved almost 50%. So you actually can size down on your pump, on your water preparation side, That's actually the unit that we can actually work on that. So this is actually talking about sustainability. Then this is actually the interface when you see in the screen. So it log in, then you can actually see all these button there. So this is a login. So we are talking about Earth, how to protect the Earth for next generation. I think this is most important thing. Then once you have this one, you will see all the piping. This is you can see cation, anion, all with the flow, with the pressure, and what is your regenerant here level. So everything is actually inside there. Everything is inside. So it's very easy to see the thing, because this is a plug and play, and it can run continuously without actually people interfere. No need to put the operator inside there. Yeah.
HEDPS is stand for High Efficiency Deionized Purification System. HEDPS is developed and cooperate between Zhejiang University Innovative Technology Research Institute, VASAR, Valve, Company Limited, and I-Chem Solutions Sendirian Berhad. HEDPS to produce high quality of deionized water, with new ion exchanged, compact bed, technology. The new compact ion exchange resin bed can help to save up to 90% of resin volume. HEDPS is upgraded from mixed bed DI system by develop the exchange zone, remove the exhausted zone, and ready for exchange zone, which both are not performing effectively in deionized process. In earlier time, EDI system and traditional mixed bed DI system are common used to produce DI water. However, there is shortages found from both deionized system. EDI system unable to remove silica effectively, and cause fouling problem. It requires higher quality of feed water, and disadvantage, with shorter service life, and higher maintenance cost. While traditional mixed bed DI system disadvantages, on consume, higher regenerant dosage, water, and required longer regeneration time. Mixed bed DI system also face difficulty in resin changing maintenance. HEDPS used to replace EDI system and mixed bed DI system, which have better performance with fast regeneration time, cost saving, easier in operation, low maintenance, and environment friendly. There is, first HEDPS install, and operating in Malaysia, which done by I-Chem Solutions Sendirian Berhad on December year 2017. HEDPS is designed fully automatically, in operation, cleaning, and regeneration. HEDPS able to produce high resistivity of deionized water, up to more than 15 megaohm consistently, with minimum operation cost. compare, with traditional mixed bed system, HEDPS able to save up to 10% of capex, 40% of opex, 90% of resin quantity, and 50% of regenerant dosage.
Any question? Not then, if any time, feel free to drop by to our booth. We can actually discuss more how if you have any project, anything. My team is ready there, so we can actually talk more details on that one. Thank you very much. Yep.